So you've probably played around with tools like ChatGPT, right? I mean, who hasn't? But have you ever stopped and wondered what's really going on inside its head? It kind of feels like this big, mysterious black box. Well, guess what? Today, we're prying that box open. We're going under the hood to figure out how these things actually think.
All right, so the brain behind these AI models is something called a transformer. Now, you've probably heard about one part of it, self-attention. It gets all the hype, all the headlines. But here's the crazy part. There's another piece, a much, much larger piece, that's been running the show from behind the scenes, almost completely in the dark. Get this, a full 2/3 of the model's brainpower, all the little knobs and dials that store its knowledge, are packed into these things called feed-forward layers. Think about that, 2/3. They're the silent giant in the room. So for the longest time, nobody really knew what these layers were for. It was just there. This was the exact mystery that a team of researchers from Tel Aviv University and the Allen Institute for AI decided to crack. They asked the big question, what on earth are these millions of parameters really doing? So they came at this with a really cool idea, a hypothesis. They thought, okay, what if we're overthinking this? What if these layers aren't doing some kind of crazy mind-bending math? What if the answer is actually something simple, something we can all wrap our heads around? And they were right. What they discovered is that these super complex-looking layers are basically acting like a giant memory bank. Yeah, that's it. It's a huge collection of simple memory cells, all working together using a system called key-value memory. So, what's key-value memory? Honestly, you use it every day. Just think about the Contacts app on your phone. The key is your friend's name, right? And the value is their phone number. You type in the name, you get the number. Simple. It's just a super efficient way to link one piece of information to another. Turns out, AI might be doing the same thing. So the theory goes like this. The AI is scanning text, and it sees a pattern. That pattern acts as the key. And just like you with your phone, it uses that key to look up a corresponding value it has stored in its memory. It's a 3-step process. See a key, find a match, pull out the value. But what do these keys and values look like for an AI? What is it actually seeing? Okay, so clue number 1, the keys. The researchers figured, all right, if this whole memory thing is true, then each key must be like a tiny detective, trained to spot one very specific thing in the text. It has to be looking for a recognizable pattern. And you know what? When they went looking, that's exactly what they found. It was wild. They found these individual memory keys that were little experts. Like one key's entire job was to activate anytime it sought text about the military that ended with the word base. Another one was on the lookout for time ranges, like between 3 p.m. and 7. A third one was a total TV show nerd. These weren't just random bits of code. They were pattern detectors we could actually understand. So, for instance, the AI reads this sentence. Aircraft from all 4 carriers attacked the Australian base. And bam, that one specific key, the one that's been waiting for military language plus space, just lights up. The pattern is literally the key that unlocks that specific bit of memory. And it gets cooler. They found the keys weren't just looking for one type of pattern. There were 2 kinds. First, you have shallow patterns. These are super simple, basically just word spotting, like, does the sentence end with the word substitutes? Easy. But then you have semantic patterns, which are way more advanced. These look for the actual meaning or topic. For example, a key might be looking for any text that talks about a part of relationship, whether it's a slice of the pie or a member of the team. It's about the idea, not just the words. And check this out. This shows us how the AI actually learns, layer by layer. In the early layers, it's all about those simple, shallow patterns. About 80% of what it's looking for is just basic word recognition. But as you move up to the later, more advanced layers, that flips. Now it's mostly hunting for those deep, semantic meanings. It's kind of like how we learn, right? You learn the alphabet before you can understand poetry. The AI learns words first, then ideas. Okay, so that's half the puzzle solved. We know the keys are pattern spotters. But what about the other half, the value? If the key finds the lock, what's the treasure inside? What information is the value actually holding on to? Well, the answer is just as simple and elegant as the keys. The value is basically a crystal ball. It holds a prediction. It says, okay, based on the pattern I just saw, here are the words that are most likely to show up next. Let's go back to our military base example. So the key spots the phrase, attacked the Australian base.
The value that's linked to that key immediately kicks in, and its whole job is to predict what should come next. In this case, it predicts words like at, on, or near. See how that works? Every single key value pair is its own little micro-expert, making one tiny prediction.
And, just like before, this predictive power gets way stronger as you go deeper into the model. In the early layers, the connection is basically zero. The keys and values aren't really talking to each other. But by the time you get to the upper layers, the agreement rate shoots up to 3.5%. Now, I know what you're thinking. 3.5% sounds tiny. But when the AI has to choose from thousands and thousands of possible next words, 3.5% isn't just good, it's astronomically better than just guessing.
So let's put it all together. We've got this massive army of tiny memory cells. Each one has a key that spots a pattern and a value that makes a tiny prediction about the future. But that's the final piece of the puzzle, right? How does the AI take all these little individual opinions and combine them to do something amazing, like write an essay or a piece of code?
Here's the absolute key to understanding this. The AI is never just listening to one of these memories. For any single phrase it's looking at, in every single layer of its brain, hundreds of these little memory cells are all firing at once. It's not a soloist. It's a massive choir with everyone singing their own note.
And because you have this whole choir singing, the final note, the layer's output, is rarely just one voice shouting the loudest. Actually, about 70% of the time, the output is something entirely new. It's a composition, a blend of all those hundreds of different predictions. The AI is literally creating a new idea by combining all these smaller ones. It's not just recalling, it's creating.
You can think of this as a kind of assembly line for ideas. A rough draft of a prediction arrives at the first layer. Then, hundreds of memories in that layer all fire at once, and they combine their knowledge to edit and improve that draft. Then they pass that slightly better version on to the next layer, and that layer does the same thing, refining it even more. With each step, the prediction gets smarter and more accurate.
Okay, so we've peeked inside the black box. We've seen the keys, the values, the layers. So what? What does this all mean, and why does figuring this stuff out actually matter?
Well, this is a really big deal for a few reasons. First, interpretability. We can finally start to see how the AI is thinking, not just what it spits out. That's huge. Second, safety. If we can understand its thought process, we have a much better shot at making sure it's reliable and doesn't go off the rails. And finally, this knowledge is going to help researchers build way better, smarter, and more efficient AI down the road.
So it turns out, the biggest part of an AI's brain isn't some strange, unknowable alien mind. It's just a memory bank. A huge, incredibly well-organized one, but still something we can understand. And if 2/3 of this complex machine runs on such a simple, elegant idea, it really makes you wonder, doesn't it? What other simple, powerful secrets are still hiding inside the machine, just waiting for us to find them?